Welcome students, this is Pankaj Singh, Ask IITians faculty. I'm working with Ask IITians since last 3 years. This chapter, Periodic Classification, deals with the classification of elements in different groups. Why? Because it is very difficult to study the properties, the chemical and physical properties of every element individually. That's why we do classify them in some groups so that we can do the study in systematic and more easier way. In this chapter, we will start with Mendeleev's periodic table, which is not actually followed today, but that is the basic and the first successful attempt in classifying the elements in some groups and periods. And then we will move to the modern periodic table, which we follow today. We will also see how the properties of elements vary in a periodic table. We will study about two laws. The first one was Mendeleev's periodic law, which was followed by Mendeleev's, and now we follow modern periodic law. We will see what is the difference between these two and what were the drawbacks of the Mendeleev's periodic table and how we overcame those drawbacks in modern periodic table. This is in fact the it is the easiest chapter of chemistry for IIT-JEE. Most of the questions which you will find in IIT-JEE exam of this chapter are based on the direct knowledge of the concept. So I will suggest you to start the question paper from the questions of this chapter and then move to the another questions. Let's start. Mendeleev's periodic table was actually based on a law which is known as Mendeleev's periodic law, and according to which properties of elements are the periodic function of their atomic weights. That means if elements are arranged in increasing order of their atomic weights, what we find that the properties of the elements are repeated after a particular interval of time. And based on his law, the Mendeleev's periodic law, Mendeleev proposed a periodic table in which he arranged the elements in increasing order of their atomic weights, and actually his periodic table was obviously based on atomic weights, and it had some horizontal rows and which were known as periods and some vertical columns known as groups. It had actually 8 groups, and each group was further divided into 2 groups. From group 1 to group 7, these were divided into 2 subgroups, A and B. Like this one, the first group, it is divided into 2 parts, A and B. So these are 2 subgroups of the group A, and this one would be known as group 1A, this is group 1-2. Similarly, group 2A and group 2B, and so on. So each group from 1 to 7 is divided into actually 2 subgroups, and while group 8 contains 9 elements and it is known as transition metal group. So this was how Mendeleev's periodic table actually looked like. And if you see here, actually this periodic table is very small in size as compared to the one which we use in reality today, and this is because at the time of Mendeleev's periodic table there were very few elements known and there were many elements to be discovered yet. So he produced his periodic table using all those elements which were at that time available, and if you see here there are some empty spaces between the periodic table, and these spaces were the important property of Mendeleev's periodic table. We'll discuss about this later. Okay, so now let's discuss merits or advantages of Mendeleev's periodic table. Actually, this periodic table helped in study of the elements. Actually, we know that it is not possible to study, or it is very difficult to study the properties of every element individually. But it will become easier if we classify them in a group, and we know that all the elements present in a group are of similar properties. So now we can study them easily. Again, this was the special quality of periodic table, that all the elements which come in a particular group have similar properties. So Mendeleev's periodic table actually made the study of properties of elements easier. First time, all known elements were classified in groups according to their similar properties. So study of the properties of elements became easier. Next one was predicting new elements. I just told you that there were some empty spaces in the periodic table of Mendeleev, and those periodic tables were, those empty spaces were actually to predict that there would be an element which is not discovered yet, but it would be discovered in future, and that would be placed at this position. So it gave encouragement to the discovery of new elements, as some gaps were left, and some of them were scandium, gallium and technetium. These were the elements which were not discovered at that time, but Mendeleev left blank spaces for these elements, and he predicted that there would be some elements discovered with this atomic masses. They will come in this group and they will show this type of properties. So scandium, germanium, gallium, titanium were the elements for whom positions and the properties were defined by Mendeleev even before their discoveries, and he left blank spaces for them in table. Another is blank space at atomic weight 72 in silicon group was left, and it was called Eka silicon. And there was some element which was discovered in future, and it was placed at that point, and the name of the element was germanium. You see here, you'll find that in silicon group, where is the silicon group? It's here, and this atomic number 72 was left blank. There was no element at that time, and as the time passed, we discovered a new element with atomic number 72, and that was placed at this point. Originally it was named as Eka silicon by Mendeleev, and now that element is known as germanium. Next is Eka aluminium, similarly another element for which the space was left, and in aluminium group, and this is like this element Eka gallium. It was known as Eka aluminium, and now it is called gallium after discovery. Similarly, another space was left empty in boron family, and it was known as Eka boron, and today that element is called scandium. This one. Similarly, Eka manganese was the empty space left for technetium, and it is here. So these were the empty spaces which were left, and these elements were predicted by Mendeleev periodic table. Now let's have a look at demerits of the Mendeleev periodic table. Obviously there were some demerits, that's why we don't follow that right in the current time. And the first demerit was position of hydrogen. Actually hydrogen resembles both the elements of group 1A, which are called alkali metals, and also the elements of group 7A. Hydrogen resembles in property with both the elements of both the groups 1A and 7A. So he was actually not able to find out, he was not able to decide that where to place it. So he placed hydrogen in 1A group, which was not justified actually. Next one was position of isotopes. This was another demerit. We know what are isotopes. Isotopes are those elements which have similar atomic number but different atomic weights. So as we know, this table is based on increasing order of atomic weights. So isotopes having different atomic weights must get different positions in the periodic table, but there were no such positions for isotope in the Mendeleev's periodic table. This was another demerit. Next is anomalous pairs of elements were left. Actually there was some pair of elements which did not follow the increasing order of atomic weights. Just like cobalt was placed before nickel in the table, but we know the atomic mass of nickel is less than that of cobalt. Just see, cobalt having atomic mass 58.93 is placed before nickel, which has 58.71 mass. So what happened, that some of the elements were there which actually did not follow the increasing order of atomic mass, and he just placed them in random order in order to justify their properties, and those were known as anomalous elements. Again, like elements were placed in different groups. If you see here, there is platinum and silver. Both have similar properties, but still they are placed in different groups. Platinum is placed in group 7, while silver is present in group 1B. Silver is here in group 1B, and platinum is here in group. So this was another demerits, that the elements which have similar properties are present in different groups. So we discussed about Mendeleev's periodic table, and we know that Mendeleev's periodic table was the first successful attempt to list all the present possible elements in a periodic table, and at the same time he left blank spaces for those elements which are not discovered yet, and he predicted their discovery. And this was the main key factor of Mendeleev's periodic table. It did have some drawbacks also, as it was not able to justify the position of hydrogen in the periodic table, and he just put some elements before with atomic mass greater than before those which have lesser atomic mass, just like here in case of cobalt having greater atomic mass than nickel, but still it is placed before nickel in order to just justify its property. And similarly, the elements with similar properties are placed in different groups. So this was some demerits and merits of the Mendeleev's periodic table. So students, in this video we studied about Mendeleev's periodic law, and based on that we studied about Mendeleev's periodic table, which was the first successful attempt to classify the elements. We know what were the disadvantages, and more importantly what were the advantages of Mendeleev's periodic table. In next video we will study about modern periodic law, and based on that modern periodic table.